Hello, this is Dr. James Camp from Lee College in Baytown, Texas, and this is an introduction to the programming language called C++. Okay, so C, the programming language that C++ is based on, was originated as an evolution of a programming language called B, and it was begun development in 1972, and development continued until 1978 by a computer scientist named Dennis Ritchie. Who published the first standard for the C programming language, the first text on it in 1978. It gained popularity throughout the 1980s until a group called the American National Standards Institute, ANSI or ANSI, standardized it in 1989. Now you'll hear a lot about ANSI C versus actual C if you get into standard C programming, because ANSI put several big standards in place about what C was and especially what it wasn't, but they kind of left it there, and other computer scientists, programming language developers, etc., kept adding little features to C, and so an ANSI C program is not necessarily, or a C program that you find out there is not necessarily an ANSI C program. It has developed a little bit over the years, though, and a new standard called C18 from that 18 is from June of 2018, so just a little over a year ago, a year and a half ago, really. They updated the C programming language, and there is now a standard called C18. What are the features of C? What is cool about C? It's designed to be terse. Okay, that is, we use fairly few characters to define things. Instead of console input, we would type cin. Instead of integer, we type int. The for loop is just for followed by 3 statements in parentheses. So this is different from a lot of other languages which had developed to have fairly wordy, at least prior to the 1970s, a lot of languages had developed to have fairly wordy syntax. It's designed to be close to machine language. Okay, and that is, you can do things in C that you can do in the assembly language that a computer is actually going to run, and if it takes multiple steps in C, it probably takes multiple steps on the machine. But this, C was one of the first to include, for example, an increment operator that you can have. If you have a number called num and you want to add 1 to it, instead of saying num equals num plus 1, you can just put plus plus after it. And this single statement, num plus plus with a semicolon, adds 1 to whatever value you have in num. That's called an increment operator. A lot of machine languages have a facility for incrementing numbers, and so that's one of those examples. Yet, while C is close to the machine language, every computer has its own machine language. An Intel chip and the ARM chip running on your cell phone, and other types of chips running in big expensive supercomputers all have different machine languages, but they can all compile from C. So it's designed to be what we call portable and cross-platform. So if you wrote a program today in C, you could run it, you could compile it for your Intel processor that runs in your laptop. You could compile it for the ARM processor that runs in your iPad or your Android phone. You could compile it for the big IBM supercomputer that the internet runs on. So, and you wouldn't have to change the code at all, because the C programming language is so boiled down that the same keywords work on every system. What else is cool about C? It popularized a syntax, okay, using, as I said, some of these short words like int and for, using curly brackets to set off a series of statements. If you wanted to do a loop, the code inside the loop or inside a function or something would be set off with these curly brackets. Popularized a set of operators, using double equals to test if two things are equal to each other, and exclamation point equals, pronounced bang equals by C programmers, to test if two things are not equal. So there's this syntax that once you learn one C language, you'll find it there's this whole it led to a whole what you might call a C family of languages, which at this point includes, of course, standard C, but also C++. I just made a C++, C#, which is Microsoft's attempt to extend C into the object world. Objective-C, which was another attempt to extend C into the object world that was used by Apple for their iPhone platform, until they came up with a new language which also is based on C syntax called Swift. And then you may have heard of this little language called Java, or another one used in web development called JavaScript. Those also use a C syntax. So this whole family, C, C++, C#, Swift, Java, JavaScript, in use today for a lot of different programming languages, all owe themselves back to this development in the mid-1970s of the C programming language. So how did we get from C to C++? In 1979 through about 1985, a programmer by the name of Bjarne Stroustrup, and I'm probably mispronouncing that name, Bjarne Stroustrup, decided that if you really wanted C++ to be a useful development language, it needed to include some new features, particularly features found in a language called Simula. Okay. Simula had introduced the world to a whole new style of programming called objects, or classes. And objects and classes are these things that combine data and the programming methods that work on that data into a single thing that represents usually some sort of real-world object. Chances are, if you've used programs that have buttons and windows and menus and all those things, each of those real-world objects is represented by an object or a class in your programming. But also, if you wanted to simulate the various parts of a chemical process running through a chemical reactor facility down the street in one of Baytown's plants, one way to do that would be to model every real-world object in that system as an object, and that's where Simula got its name, as it was supposed to simulate real objects. But Stroustrup found that Simula, the way it was designed, was a fairly slow language, a little bit painful to use, and did not lend itself to easy programming. So he merged it with this relatively new language called C, which had the advantages of being fast and portable, as we mentioned, from one computer to another. And at the time, it was pretty popular. It still is. So when he put Simula and C together, he got a new language that he called C++. And if you remember from the last slide, the ++ operator is the operator in C that adds 1 to a variable. So if we take the whole programming language C and we ++ it, we get a new language, the next language in the row of C. Microsoft did something funny with their C# that they added another ++ to the C++ and got C#. Which is also a play on the fact that in music, a sharp is one note higher than a normal. So C# is a step up from C. Okay. So, and C itself was the next letter after B, which was the programming language that came before, that everybody used before C. So, as you can see, programmers love these little plays on words and numbers and things. Okay. C++ has been standardized not by ANSI, but the International Standards Organization, or ISO. So it's been ISO standardized since 1998. And that first developed standard was called C++ 98, just like we had C89 and C18. It was left alone for a long time to just sit and incubate, and people, different programming language developers or programming environment developers added different things to C++, and it was becoming an unstandardized mess again. So around 2011, they decided to make major updates to the C++ standard, and so it's now been updated to keep up with trends in computer science about every 3 years since 2011. So we had a C++ 11, a C++ 14. The latest edition is C++ 17, so when you download your compiler to get ready for this class, you want to make sure it's a C++ 17 compatible compiler. And the next one that they're working on right now is C++ 20, which will come out sometime during this calendar year, 2020. C++, as we mentioned, has objects and classes. It has all sorts of advanced features that we probably won't have time to get to in this class. But it also has C's fast, portable, and very close to the hardware language that makes it a very fast language when it's compiled properly. For all of these reasons, C++ is now considered the 4th most popular by some indexes. Rating programming language popularity is a big game on the internet. You'll see lots of different sites out there claiming to rank the most popular languages, but at least one of them has C++ as the 4th most popular language, behind C, Java, and Python as the other 3. I don't remember what order those were in, but C is still, despite its lack of objects and advanced features, one of the most popular programming languages because you can write very fast, very hardware-specific programs for it. Okay, so let's now take a look at writing our first C++ program. C++ programs tend to be fairly long and short, so I'm going to develop us out here a area to write our program that starts here and then kind of wraps around like that so that we have room to write the whole program. Okay, now the first thing you will write in any C++ program are compiler directives that are not actually programming language statements. They are there to tell the compiler which parts of the C++ library you plan to use in your program. And the syntax for that is a pound sign. You'll recognize this as the same sign that's become popular as the hashtag symbol on Twitter, and the word include. This is pronounced pound include by C++ programmers. And then an angle bracket and the name of the library. We're going to use the IO stream, input-output stream library in this program. And we're also going to pound include the string library in our simple C++ program. The next thing you'll need to do is use the keyword using and the keyword namespace. Not used to coding in handwriting. And then the namespace that you're going to use is std for standard. Let me write that a little more neatly. std. In keeping with the terseness of C and the idea that this programming language is supposed to be very easy to type, the standard namespace was reduced to the first 2 and the last letter in the word standard, so std. It's kind of unfortunate because since the 1980s, after this was developed, STD has taken on a new meaning, and a rather unhappy one. But they didn't think about that when they wrote the language. They just thought of this as an abbreviation for standard. Now, one thing you'll notice real quick is that I ended my line with a semicolon here. Semicolon is the punctuation that C family languages use to end a line. You'll notice I didn't put a semicolon after my 2 pound include statements because those are compiler directives. They don't count as actual lines of code. Okay. Now, once you've established what namespace you're working in, and namespaces, I will just add real quickly, are a tool C++ invented to help organize very large programs. Okay, people use C++ to write really large programs like Microsoft Excel or like the Windows operating system itself. And so in using this, you might have the same variable name come up several times in parts of the program that were written by different people. And so by organizing each person's work into a different namespace, you can keep those names separate and not have to have everybody coordinate about what variable names they use. Okay. Once we've established our namespace, once we've done our pound includes, now it's time for any kind of global, what are called global variables. They're global because they apply to the whole program. It's pretty bad style to use global variables these days. People don't frown, kind of frown on it, except with the exception that global variables are good for defining constants that are going to be used throughout the program. So we're going to have a string constant called greeting that's going to be used throughout our program. Now, I could actually make this even more clear and help the compiler out a little bit by using the const keyword. Again, we're keeping this terse C language where we abbreviate everything. So instead of constant, I say const. So if I have a const string named greeting, that tells the compiler that I'm never planning to change the word greeting. I'm just planning to, or I'm never planning to change the value of greeting once I set it. And I'm going to set it here to hello. Okay. Now you'll notice I again ended the line with a semicolon. Forgetting those semicolons will be something you do all the time when you're writing C++ programs, and the compiler will keep yelling at you with strange error messages until you realize what they are. Notice also here that I put if I want to use a string of text, I have to put it in double quote marks. Okay, just like a quote in a textbook or something. I have to quote it hello. Now, because this is a constant string greeting, I can't decide later in my program that I want to say howdy or bonjour or aloha or something else as my greeting. It's constant, it's fixed. Once I've set the value, it's there. Okay. We can use that later in our engineering programs to define useful constants like constant double pi equals 3.1 1415926 can't actually put ... in C++. We'll get mad at you. Okay, so we can define pi to as many digits as we happen to know, and then put a semicolon there, and that constant will remain constant for the rest of our program. Okay, I'm going to erase pi because I'm not actually using any trig functions in my my greeting program here, but that's just to show you that you can do that. Okay. After global variables comes something called functions. Okay, there are functions that return a value, like cosine of x returns a value, and there are functions that just do things. The first, to declare a function that just does something and doesn't return a value, we use the keyword void. Okay, so I'm going to declare my void function. I'm going to call it greet. Okay, and functions can take parameters. Some people call them arguments. Okay, and in this case, I want to send a string type argument called name. Okay, because I want to have somebody to say hello to. Okay. We start the function with a curly bracket, and then in this case, our function has a single line. It just does cout. We'll talk about input and output in another presentation, so don't worry if you don't understand this. I send it the value that I stored in the constant greeting, and then I send it the value that was passed to me in name, so that's going to make it down there. Okay, this greeting over here is going to make it to there. And then I pass cout one last keyword, ENDL. That's an L, not a 1. Stands for end line. Okay, so that tells C++ that I'm done with my line of text. Okay, so this will print on the screen hello for greeting, and then the person's name. Okay, I have a couple more functions I need to write. I want a function that gets the user's name and asks the user for their name and returns it. So this is one of those functions that returns a type. So instead of void, I have to tell C++ what type of variable to expect. So the type of variable that would carry someone's name is a string. Okay, and then my function is called getName. And getName is going to do the same thing every time. It's going to ask somebody for their name and return that name to me. So I don't need to pass it any parameters. But to tell C++ that this is still a function, I have to put an empty set of parentheses after its name. Okay. Start my function with a curly bracket. This time I've got several things that are going to go on in this program. First, I have to declare a variable to get the name with. I'm going to call it inName. Okay, and I'm going to call it that for two reasons. One, I want to distinguish it from the other name that I used over here. But two, I want to show you that you can put underscores in variable names to in place of spaces. Okay, you can't use an actual space in a variable name, but you can use an underline character to act like a space. Okay. Then I'm going to use cout to display a message on the board or on the screen. And this time I didn't store my greeting as a constant, so I have to pass it right here. So I'm going to say, what is your name? Okay. Notice I don't have to put an end line on this one because I want to have the person just write their name on that same line of text. I could put an end line and have the person write their name on the next line of text. That's a programming style issue. That's up to you to figure out how you want to do it. Now I'm going to use an inputs function called getLine. Okay. Where am I going to get line? I'm going to get it from the console input cn. And what am I going to get the line to? I'm going to store my input in this function inName, in this string that I declared earlier, inName. Okay. Now when I'm done with a function that returns a value, I have to use the keyword return, and I have to provide return with a value of the right type to send back to my program. Okay, so there's my getName function. You can see what it does. It outputs what is your name to the screen, it gets the user's response, and then it returns that. So that means inName goes here and gets passed on to whatever function called this. Okay. Now I still haven't written my main program. Okay. In every C++ program, the main program is what you write last. Okay, it may actually be what you write first, but it comes last in the program code. The main program is always type int. It's always named main with all lowercase letters. Okay. And here I'm going to declare a string type variable called whosit. Okay. And I could just declare it like that and then give it a value on the next line. But C++ lets me do multiple things on one line, so I can declare this and then I can set it equal to the return value from my function getName. Okay, so what does this line of code do? It calls getName, so it sends us up here. It runs each of these lines of code in a row. It returns the name that the person got. Okay, and it sets that into my new string called whosit. Okay. Now I'm going to use my whosit and I'm going to pass it to my function that I wrote earlier called greet. Greet whosit. What does that do? That passes program control over here, passes the whosit variable into this string name. Okay. Name goes down here and gets used with the greeting, and then there's nothing to return, so we just come back and we're ready for the next line. Your program in C++ will always return a value 0 unless something went wrong. 0 is the universal computer signal for no error code, nothing went wrong. Okay. So you can now see a complete computer program. We start here by declaring a string whosit. We call getName Get name asks the person, what is your name? Gets a name, returns that value, and adds it to who's it. Okay, we now take who's it and we pass that value to the greet function, and it also pulls the word hello from our constant string greeting, and so it's going to take the name that the person just entered and say hello name. So if I typed in Juan Valdez, it would say hello Juan Valdez. Okay, then it returns. There's no value to return, so we just go to the next statement in the program, which is return 0, and that ends the program by telling the computer that there was no error with running the program. Okay, so that's your first C++ program. I hope you get the hang of all of these pieces and how they go together, and then I'm going to go through in the next several videos and outline what a string is, what an int is, how the input and output, cin and cout work, and many other questions that you may not even know to ask yet. Thank you very much, and have a good day.